Lim-san, please use microphone.
Today's talk is given by Tatsuya Kawakami, and Tatsuya is final year master's student at Graduate School of Information Production and Systems, Waseda University, Japan. And Waseda University is one of the most prestigious universities in Japan. And this campus is in the south of Japan. The main campus is in Tokyo, which is the capital, towards the northern side of Japan. So if you know about the map of Japan, so it's like a strip of islands. So this is the bottom. So his talk would be on tokenization of skeleton-based post-attention model for cross-view gait recognition. So I would welcome Tatsuya to continue with this presentation. Thank you.
Hello, this is Tatsuya from Japan. My major is image processing and information processing. Today I talk about get recognition techniques in working method. So in this talk, regarding one method appears, and I simplify each method so this you can understand. So let's start. So get means involving method. It is used for biometric identification. Here I show some data information from visual information. So first is for silhouette, like this, and second is RGB image. So Gait is a unique tool for biometric identification, which compared other biometric identification tool. So iris, fingerprint, and face. If people appear at long distance in the camera, we can identify each people. Also, it's ground floor facility, hospital. So, in every industry, there are two applications, and one is security system. So, this is used for back to security camera. Also, this is used to entrance system. This can create the keyless system. So also this is used for finding disease. So when doctor can find the disease for patient, they can find this disease in early session. These are advantage for Gait. So my term is cross-view gait recognition. So what is cross-view? So for obvious gait recognition, visual gait recognition is conducted for single view. In single view gait recognition, people appear from same point and they go to the same way. So I'll show you this figure. But in air station, in the camera, people appear from different position and they go to the different way. And to focus on cross-view gait recognition is step. So in the cross-view gait recognition, people appear from different points and they go to the different way. In the cross-view gait recognition, it is hard to identify this. Hard to identify them. So in the single view recognition, it is easy to identify them. So I introduce you the OUML database. So this is first large population get database with a large view. So it is people take the video with the 14 video camera. So there are seven with the 14 video camera takes the people walking scene. So here I show these examples. So then the matching is conducted from the 24 by 24 combination. So there are results of 196 kinds of results. Here I introduce you for detailed identification method. On the OUMP identification task is conducted like that. So first, 100 people, 5,153 people is training for neural network. After finishing the neural network, and remaining 100 people is used for test. So in the test section, the test set is divided into carrying data and proof data. And carrying means data which we know is identity. And then we want to identify the proof data's ID. So first we process all carry data as a specific view on the first data. So every has two working data. So one first get data is used for carry data. The second data is used for proof data. So all carry data is processed. It processes each proof data on specific view. So after processing each proof data, there's an identification feature. Then we find the most similar data from carry database. So we give it in process for all proof data. Then we do the accuracy. So then there are sometimes all result of every recognition. So this accuracy means the average score on the 40 by 44 combination. So there are 196 results. Then we get the average result as the accuracy. So the precaution is categorized into two parts. First is called appearance-based method. Second is called model-based method. Appearance-based method takes a visual impression like silhouette. But the silhouette, this problem is weak for bias. So in this example, the half part of body is hidden by the camera angle. So this lack of information makes the file of identification. So model-based method is created. Model-based method takes the human model like this. So this model is created and with neural network from RGB image. Then this model has the 24 joint with three coordinates. So this is in the x-y space. So this has a 3 kinds of coordinates with a 24 joint. With care, this is video data, so there are not single frame. It has the 3 this is time series data and it has many frames. So in my research, I focus on the model-based method. So in my research, I want to improve this result. As a related work, CNN has the correct result of model-based method. So now I want to introduce you the CNN. CNN is a method to process the image. So there are input data, there is the image as input data. So then kernel is used for parameters. So this is neural network method. This parameter is updated to optimize the result. So first, synthesize at this panel size varies from image. Then this we have calculation 2 by 1 by 0, 1 by 0, 1 by 1. Then we add the all value. Next, we extract the 1, 0, 1, 3. Then we multiply this image information and panel. Then we calculate the 1 by 1, 0 by 0, 1 by 0, 3 by 1. We repeat the process with this extraction. Finally, we get this result with this extraction. So then we got the result like this. For CNN, with the CNN, this 3 by 3 information is summarized into 2 by 2 image, 2 by 2 result. This is method of CNN. In CNN code, first the pseudo image is created. Pseudo image has the joint position on each pixel. So, as I mentioned, there are 24 kinds of joints, and it is in XYZ space. So, there are 24 by 3 pixels for each row. So, we extract each joint position for each row, and we repeat the process for break times, number of break times. Then we get the pseudo image. After we get the pseudo image, we process this pseudo image with CNN method. Then we get the identification feature. After that, after we get the identification feature, we do this matching method to the find most similar data. At the average score, CNN code gets 48.6 accuracy. So this is high accuracy in the model-based method, but the result is better. Appearance-based method has a better result. So in my research, I want to improve this result. So the CNN code problem is it takes the information on the neighbor point. So CNN, as I mentioned before, CNN extracts the neighbor information. So this is called local information. So this can take the relation between the first frame and last frame. Also, it is proven to it takes the all feature equal. In Gait regulation, the key point is arm swing or left behavior. So head movement is not so important, but this information is used for keyboard. So in my model, I want to regard this information in my model take care around overall frame, not only the adjacent frame, overall frame. Also, I want to enforce important feature, not use equal like head and arm. So I want to include key information for Gait. From the next page, I explain about my method. My key point is these three topics. First, I convert joint information to the token. Token is a representation for my model. For representation as an input for my model. Next, attention-based model. My model is attention-based model. Attention is used for extract the key picture from the model, human skeleton model. Finally, I divide token into some parts to enforce the value of attention. These 3 points are important points on my research. First, I talk about tokenization from skeleton model to token. As I mentioned, skeletal model has 24 joints in the x-axis space. So I set each joint position to vector. Then I place a vector. So this vector is size of this vector is going to be 72 means 24 by 3. So I line up x position, y position, and z position. So this is vector, but this is position for my model. This this converting method is my first idea. Also, that is a time series data. This has many frames. So I made this converting method for all frames. Then I put the number of frames total. This is used for input. This is used as input for my model. Here I show you my model, my overall model. This is based on neural network model. So the input is token that I create the last page. So then some architecture works to enforce this feature, this new feature. Finally, I get the identification feature. So then I discuss identification as recognition. First, I explain about input entity and personal encoding. Input entity takes the token to expand the optical range. So input is 72 dimensions. 72 means the number of joint by 3 coordinates. So then I expand this feature to 128 new dimensional new vector. In this dimensional expansion, I use that Fourier collection. Here I show Fourier collection method. So there is a this Fourier collection example Fourier collection is 3 to 2 Fourier collection. So then there are 3 by 2 parameter and weight. So there are 3 input values. Then these 3 ways are used to summarize this information. First, we multiply 3 by 1, and we add 2 by 1. Then finally, we add 1 by 3. This calculation result is a first regression result. Next, we calculate 3 by 2, 3 by 0, 1 by 0. And we add this result and we get the result, some result. This is method to reconstruct. This is most common method for neural network. Then we get the new dimensional token. This is called embedded token. Then we add the new dimensional vector to embedded token. This size is 128. This is same as the embedded size. So this is optimizable parameter in the neural network. So this gives it to time series information. So network optimizes this parameter to escape the time series information. This is the first processing. Next, I talk about post-attention. Post-attention is the important point of my model. So there are n kinds of embedded tokens that I explained in last page. So I line up each token to create the matrix. So this size of this matrix is 128 by n. Then we apply new Fourier connection, and then we use the 3 times of weight. First is W weight, second is W base, third is W2. This Fourier connection summarizes each information to one set size. Then we get a Q, K, and V as a 3 kinds of parameter. This is used for input. This is used as an input of similar frame. This is similar to income production. After this, then with this calculation, we can get the enforcer feature, first enforcer feature. Next, we calculate this, we multiply this result and value. This calculation works to find the enforcing signal pose. This is key point on my method to get an enforced feature. After these two kinds of calculation, we use the enforced and tokens. After this calculation, after this observation, we take the max by view selection. In the n kinds of tokens, we set the maximal value for each index. So this time was 128. We set the maximal value on each index. So we can get a single vector with 128 size. This has only enforced feature. So this feature has an information which summarized with this type of information. After this processing, we expanded this feature to the identification feature, then we use the pre-collection. After that, we expand this feature on number of subjects. In my case, in my own OU-based database, the working number is 5,153. So then we expand this feature to 5,153. Then we get the loss, two kinds of loss. Loss is used for updating network parameter, updating neural network parameter. So first is called center loss. Center loss takes the distance between the identification feature and the center of category. Center of category is set before starting running. So then this distance is we take the distance to calculate the loss. In case of this distance is short, we update parameters right. In case of this size is long, this distance is long, we update the network parameter significantly. This is about center loss. Next is max loss. So I mentioned I expand this identification feature to number of subjects. Then we can index the ID of its data. So the network can, if network can predict the correct ID, we don't update the network parameter. If the predicted ID is wrong, we update each parameter. This is for max loss. That's all about my method. So here I show you my method. Upper method, I did this matching method. So this is I wrote our first section. Upper method has the result of CNN code. This is the way it works. The bottom method has the result of my method. Result was improved more than 10%. Also, I did a thorough experiment. So then, first I used the single token to take the observation. Then, now I divide first token, single token to three kinds of token. A token is consists from X position, Y position, and Z position. So then I divide original token to three tokens. Then each has only X position, only Y position, and only Z position. Each is processed with the attention module. Then we combine the three kinds of features. Then we calculate the identification feature with the reconnection. As second method, we add the original token and three kinds of divided token. These are my additional experiments. Here I show you these results. So this was result on CNN pose. So this is my last result. This is three kinds of result on three kinds of tokens. The final table shows the result is four kinds of tokens. This was where the result is compared as a result. So this is all about my experiment. Let's go to conclusion. So my idea was converting both skeletal model to tokens. So this is used for input for the attention module. So then attention extracts the key feature and the key feature for get recognition. Also, function method enforces the attention box. So then I get a greater result with divided tokens. As a future work, my method takes the only all what is information right is including head, elbow, foot behavior. So I should divide this relation and I think I should take each relation like arm swing and foot legs behavior. Then so I should each relation I should use the cross attention. Cross attention takes not only one input, it takes some kinds of input. That's all about my presentation. Thank you.
There are questions. You may please ask. Feel free to ask.
Microphone.
I can't hear you.
Like how will you capture the joints of like any specific person? What kind of model are you using for capturing like you are doing joints? Right? Joints. So joints from images, how do you capture the joint?
Okay. It is a provided data, so I don't create it. So I will explain about how to create it. So this is explanation about how to create a joint model. So this is used for multiple training. So first, this is divided training section and inference section. In training section, some combination of loop is used for training, and then this is example of combination of 19 angle and 15 angle. Then two kinds of input is used to post estimation. Then neural network is used. So after then the process calculated and most updates the neural network parameter. Then this parameter is shared with the inference phase. Then if it's an inference phase, just single image information is used for this. Then the from single view, most is estimated from single view.
different from normal features. For example, these joints features would be XY coordinate.
Yes.
But when it gets changed to tokens, how will it get changed? What is the difference between that feature and token?
Okay. So information is not so far from between the both and token. This has joint position on each joint. I just line up this joint position, and this is then I call this a token for input or post attention.
So token is a combination of XY position features.
Yes. Just line up each value.
And how do you, I did not get how the attention is assigned. Can you explain once more?
Yes. First, I processing the input token to a new size. Why I update this token is this size works strongly on the attention. And then I line up each token to create a matrix. Then I create the three kinds of parameters to use the attention. First is Q, second is K, and third is value. So then I use the Fourier function. So then I get the three kinds of parameters. So first I collect the Q and transpose the K. And this calculation works to find the Shimura frame. Also, next I calculate this result and value. Then I calculate the Shimura force on each joint, for each frame. Then the enforce, if the person has the similar force on the single Gait data, the similar behavior is enforced with in this matrix, this output matrix. This is called attention.
How do you determine the values of Q, K, and V? V is the feature, or what is V?
These are created these neural network parameters. So these are optimized on the network.
And last results. What is 000 015 till 2070? What is
Okay. This shows the envelope and
until 15 degree, 30 degree for
yes. So each curve shows the result on average score on each group view. So 000 means the 000 group view. 051 means the 051 group view. So there are 40 carry view. So this score is the average score on 40 kinds of result.
How does the result look on real data? If I capture any real data in the laboratory rather than the data set, have you tried that? Whether the data results are similar to it? Have you tried it on any other data set which is created by you, or only one data set did you try?
So my model takes the skeletal information, joint information, right? So this 3D joint model is created by Osaka University. To estimate this estimator is only Osaka University has this estimator. We can't use this method. So we can use only this published data. So we can't use the original data as new original data.
Do you have any other questions? So we were also thinking if any one of want to ask about general things about Japan. You might know about things about Japan. Maybe if there is any general queries, can they ask and will it be possible for you to answer? Yes. If they have some general queries about Japan.
About anime or about manga, about popular culture. Do you have any such questions? Do you have an anime question?
One question. There is a famous cartoon in Japan, Doraemon. Is it really possible in future or
Famous what?
you know Doraemon, right?
So in India, this cartoon called Doraemon, which is, do you know this?
Yes, of course.
So is it possible in reality this kind of robot?
The kind of robot which is there in Doraemon. What is your opinion? Is it possible in real life?
Its conversation is very great. So nowadays, generative AI can achieve it to create a Doraemon, I think.
Can you explain it one more time? I did not have. We have many ones. Can you explain your answer one more time, please? What you just said now, can you repeat it one more time? Repeat it.
Yeah, Doraemon's questions answer. You should keep it. Repeat it again.
Do you think it is possible, a world like that?
So your question means how to create a Doraemon.
Are you asking how to create Doraemon like that?
Yeah. So most difficult point is how to create its brain, what's of brain, Doraemon's brain. So I think nowadays generative AI is developed, so a new generative AI can achieve the brain to create the brain of Doraemon, I think.
Good answer.
Little bit of complicated. For carbon images, I was saying that you have collected about 10,000 papers on this thing. The subjects. There are
About research?
yeah. So it's 10,000 papers subjects. Number of subjects.
In that database contains 10,000.
10,307.
In terms of data,
So it's from public library, right?
about data.
The number of people you have collected. It's 10,000, more than 10,000.
Where, are you asking where we got it?
So is it a public library thing?
So his question is, this data set, is it a publicly available data set?
Okay. Let's see. So this is published Boston University. So I can there RGB image and silhouette and joint data. We can only use only silhouette or skeleton because this RGB image is protected with the copyright.
Okay.
So Boston University can only Boston University can use RGB data. We can use only silhouette or skeleton.
So you will be rotating the image, right? So what was the right of original number of images you had? So you could actually rotate the images to increase the possibility, like left, right, up, down. So did you do that? So revisit it with the question. So usually, like,
So you can rotate it. So I asked you
to
number.
write the model better, you could actually rotate the images.
Augmentation.
Augmentation. So better train the model.
Rotation and all that's part of augmentation when you train it.
Actually,
Train it.
for the training, you would actually rotate it. The same image, you would actually train it.
So his question is, when you train DNNs, you do augmentation.
Augmentation.
So you will not be doing augmentation.
To create skeleton data. Yes. So to create this model, augmentation is used. In its augmentation, the joint position is estimated. So if we can create a model which augments the human joint position with a multi-view or 3D joint, we can create a much better model.
ちょっと please show us detail about the reference tools なんか、literature's data information in the last page. Yes, yes. Two. Reference to is this the journal's paper. Two is the Osaka University's data set.
Yes, so this number one is the Osaka University's paper. So this, in this paper, the 3D joint model is developed. So in this paper, the estimator is explained. Also, other methods of data recognition. So about the extent is only this number one difference.
But you mentioned about the data set is referred in the reference to, right?
Reference to is just data recognition method. This is not about
Okay. Data set itself is open to public in some site.
yes. Number two also database. About
Database is mentioned in this paper, right?
yes. Number one and number two create a database.
Okay, understand? It's okay.
I have a question regarding Japan, so regarding the
Yes, please.
So as of now you are a master's student, second year graduate associate.
Yes.
So in Japan, how is your education? What is the mode of language you use for education? Is it English or Japanese? How is the whole education system in Japan? Do you know the medium of
So all students, most Japanese students use Japanese. So as my school there are no less Japanese. There are too many exchange students. So we should speak English in my school. But most graduate school students speak the Japanese in Japan.
so your materials and textbooks or kind of used in Japanese? Reading materials.
Yes.
Not in masters, I think Professor Matsumaru teaches in English.
This university you mentioned like
The
So
question
it was
is all textbooks and all in Japanese.
Most of them is using in Japanese textbook, but of course our school is using the English for the lecturing and the teaching and the supervising. So therefore, some English textbook or English some reference book is necessary, of course. Right?
Thank you.
I would now invite Dr. Rachel to give a token of appreciation.
Okay.
Even those of us who are not from the background to understand.
Thank you.